Hello everyone. In this video, we will discuss about the sample and hold circuit, isolation amplifier, and chopper amplifier. Three topics we will discuss. Okay, sample and hold circuit. First of all, we will discuss the sample and hold circuit. Whatever the topics which we cover in this class, they are important for short questions in semester exams. Okay, sample and hold circuit. The sample and hold circuit is used for sampling the input signal and hold that one for some period of time, and one of the practical usage is it is especially used in the analog to digital converter. It is especially used in the analog to digital converter. Instead of analog to digital converter, if you want to exactly realize where exactly we use the sample and hold circuit means, whenever the device which is not working with the same speed of the input signal, means input signal is varying with certain frequency or the certain time period, and the device is not working with the same speed, then obviously there is a mismatch. Means whatever the device which is used for measuring the input signal, if it is not working with the same speed of the variation of the input signal, then obviously there is a mismatch. Means we may lose the actual data. We may lose the actual data because at a time period, let us suppose I am taking this example. Uh, Let us suppose, yeah, I'm assuming that this is my signal. Input signal is there, so I'm assuming that this signal is varying. It is analog signal. I'm just taking one analog signal which is varying with respect to the time. And if at all I'm having one, what is that? The device which is trying to measure the input signal. Okay. So let us suppose this device, let us suppose this particular device is measuring the input signal with a time period of 2 milliseconds or 3 milliseconds. Let me take the 3 milliseconds. Okay, with a time period of 3 milliseconds means for every 3 milliseconds, this particular device is measuring the input signal. This particular signal device is measuring the input signal. Why it is taking the 3 milliseconds means I'm assuming that the input, this device is accepting the input signal and doing some process inside it and displaying on the screen. For that, it is taking the 3 milliseconds. Assume that the input signal is varying with the time period of 2 milliseconds. So obviously there is a lag. Means if this one is varying with the 2 milliseconds time period and this one is measuring with the time period of 3 milliseconds, obviously this device is not measuring each and every variation in the input signal. Each and every variation in the input signal. Okay. So means if at all this signal at the time of this at the time of measuring, let us suppose it is measuring the signal at this point. Means we may lose the data at this point and we may lose the data at this point because it is measuring after every 3 milliseconds, but the signal is varying with the 2 milliseconds. Okay, the signal is varying with the 2 milliseconds, with the time period of 2 milliseconds. So obviously the measured device is not accurate one, means it is not measuring each and every variation in the input signal. It is not measuring each and every variation in the input signal. So in order to avoid this kind of problem, we have one device called as a sample and hold circuit. We have one device called as a sample and hold circuit. What this particular sample and hold circuit is doing is S slash, we used to call this one S slash H sample and hold circuit. What this device will do means whenever there is a mismatch between the two components at that time, the sample and hold circuit samples the input signal with the same time period. Samples the input signal with the same time period and holds this particular circuit. The sample information will be stored by the sample and hold circuit for some period of time. And whatever the information which is stored by this particular sample and hold circuit, that information read by the measuring device and displays the information. Means for every 2 milliseconds, means with how much speed the input signal is varying, with the same speed the sample and hold circuit is trying to sample the input signal and holds that one inside the circuit, and whenever the measuring device is ready, it will read the information from the sample and hold circuit. So with the help of the sample and hold circuit, what we can do is whatever the mismatch is there with respect to the time period of input signal and the measuring device, that will be overcome by the sample and hold circuit. Mostly if you want to see the practical scenario where exactly we use the sample and hold circuit, we are using the sample and hold circuit in the analog to digital converter. We are using the sample and hold circuit. One of the example, we are using the sample and hold circuit in the analog to digital converter. What this particular analog to digital converter will do now, it will convert the analog information into the digital format. Let us suppose this input signal is this one. The analog input signal is this one, and this analog to digital converter is having the conversion time. Okay, now it will take some time to convert the analog information into the digital format. The analog information into the digital format. So if at all the analog to digital converter is speed is not matching with the input signal variation, to avoid the losing of the data, actual data which is there at the input of the analog to digital converter, again we are using the sample and hold circuit. Means if at all the input signal is varying very fastly and the analog to digital converter is converting, it is also working with a high speed, but in order to avoid the losing of a fractional variation in the input signal, they are using the sample and hold circuit in the analog to digital converter. Okay, now so they are using the sample and hold circuit. Now this entire thing becomes a, what is that? This entire thing becomes our analog to digital converter. Okay, analog to digital converter converts the analog information into the digital format, but this particular analog to digital converter is preceded by the sample and hold circuit. What is the use of the sample and hold circuit? Means it measures the, it samples the input signal with the high rate and holds that one. Analog to digital converter reads the information from the sample and hold circuit and converts that information into the digital format. That is the main intention of the sample and hold circuit. And we have one practical point also over here. Whatever the sample and hold circuit which we are having, with how much frequency it should sample the input signal. With how much of frequency it should sample the input signal is a question. Okay, so that is measured with mostly we used to call that one as a 1 by t or 2 by t. Okay, so means twice the input signal frequency. In simple statement, if you want to know that one, it is a twice the input signal frequency. Okay, so means sample and hold circuit is nothing but it looks like a what is that, on off switch mode. It looks like on off switch. Let me take this one. No, wait a minute. It looks like on off switch. Okay, so whenever it wants to sample, it closes the switch. Whenever it want to it don't want to sample, then opens the switch. So analog to digital converter is nothing but it is a switch along with the storage element. It is a switch along with the storage element. So I'm assuming this is a storage element. The sample information, it will be stored inside this particular element. From here, the analog to digital converter will read the information. With how much rate it should sample the input signal frequency means, let us suppose the input signal, with how much rate the sample and hold circuit, this entire thing called as a sample and hold circuit actually. So this entire thing, what we are having, this entire thing is called as a sample and hold circuit, which is having the, what is that, switch, on off switch. It looks like an on off switch and one storage element. Okay, this entire thing is a sample and hold circuit. This switch is going to be on and off. This switch is on and off with a frequency of twice the input signal frequency. Or I can say that it is a if I am assuming the input signal frequency is a f, then the sampling frequency is twice the input signal frequency. F. So it will means it will open and close this particular switch with a frequency of 2f, or in time period we used to call it as a 2 by t. Okay, it is a twice the input signal frequency. With that rate, the switch should be open and close. Then only whatever the variations are there at the input of the sample and hold circuit, they will be sampled perfectly by the circuit, and it will be converted perfectly by the analog to digital converter into the digital format. Okay, so whenever we are using the sampling circuit, sample and hold circuit, or the sampling theorem, here we are applying the sampling theorem actually, but we list about the sampling theorem. There that terminology, sampling theorem terminology, is used in the DSP processor case, but the sampling rate, however the sampling rate we are using, sampling means with how much speed we are sampling the input signal, that frequency should be twice the input signal frequency. In short, if you want to avoid the losing of any data, any variation in the input signal, then this switch should be open and closed with a rate of twice the input signal frequency, twice the input signal frequency, twice the input signal frequency, right? So this is what we are having. Now let us go for the explanation of the sample and hold circuit. So means this is a brief explanation of the sample and hold circuit. Let us see the circuit diagram explanation of the sample and hold circuit. Circuit diagram explanation of the sample and hold circuit. So here, if you see this one, as I told you that we should have one sample and hold circuit, means we should have one storage element, as well as we should have one what we say storage element, one switch. That is a switch followed by the storage element. That is nothing but the sample and hold circuit. If you see this diagram, here we are having the E MOSFET. Now this is a E MOSFET which is acting as a which is acting as a switch. And here we have the one more element called as a capacitor. This capacitor is the one which is acting as a storage element. This one is acting as a switch. This one is acting as a storage element. And the input signal which we are supposed to apply, this entire thing, if you want to take this entire thing, commonly call it as a sample and hold circuit. Actually, we should consider the entire part which is amplifying the input signal. But if you want to see whatever the diagram explanation which we have seen, then up to this part, this is a switch and this is a holding circuit. So this entire thing acts as a sample and holding circuit, and the hold information should get amplified to drive to the next level of the device. So that's why we are having the operation amplifier, which is nothing but the voltage follower. The output follows the input only, but the output is having the high intensity signal. Output is a high intensity signal. Output is a high intensity signal. Now, so here we are having the what is that? A switch. Now this one is acting as a switch. This one is acting as a switch. So this is a drain and this is a source. This is a gate, and here we are using the E MOSFET. E MOSFET. Whenever we are applying the, as per the E MOSFET statement, whenever we are applying the positive pulse to the gate, then the switch, this particular MOSFET is acting as a closed switch. Whenever we are applying the zero voltage to the gate, then this particular circuit is acting as a, this particular E MOSFET is acting as a open switch. So close switch is closed or open. So means if you want, I can say that this MOSFET is acting as a switch only. This MOSFET is acting as a switch. Okay, so this switch will open and close based on the input voltage which we are applying to the gate terminal. So if the gate is if we are applying the positive pulse, that is a plus 5 volts, then the gate will be closed. If we are applying the negative pulse, it is not the negative, zero voltage, then it will get open. So one is a closed circuit, another one is a open. So in order to switch on, switch off this one, in order to switch on and switch off this particular E MOSFET, which is acting as a gate, which is acting as a switch, which is acting as a switch, I'm using the one source. I'm using one source. This particular source is having the what is that, square wave. It is a square wave. In order to give the explanation, it is a square wave. Positive pulse is a plus 5 volts and the down pulse is a 0 volts. Negative pulse is a 0 volts. It is acting as a square wave. Means I'm applying the pulses continuously to the gate terminal of the E MOSFET. Based on the pulses, the gate circuit, this particular gate terminal may switch on and switch off the E MOSFET. Switch on and switch off the E MOSFET. Whenever the gate receives the positive pulse, then it will switch on the this particular gate, and whenever it receives the active there is a low pulse which is nothing but the 0 voltage, then it will open the switch. Means the gate is in MOSFET is in the off mode, not in the on mode. Okay. So like that, the input signal, whatever the input signal which we are trying to sample, that input signal is applied to the drain terminal of the MOSFET, and the source is acting as a output terminal, and the gate is acting as a controlling the switch. Gate is acting as a controlling the switch. Whatever the voltage which we are applying over here, that is called as a sample and hold control voltage. Sample and hold control voltage, which is represented with a symbol with a variable name V suffix S. V suffix S, and this is actually this pulse now. So if you want, you can simply see this one. So this is a what is that, VS signal status. So high pulse and the low pulse. High is a plus 5 volts, low is a 0 volts. So this pulse we are applying to the input of the gate terminal of the MOSFET, which is acting as a switch, and this is the input signal which is varying with some frequency. So here when this particular switch is closed, let us go for the explanation of the circuit diagram. Let us go for explanation of the circuit diagram. Okay, so when this particular switch is closed, means I'm assuming that this one is in the means we applied the on signal. We applied the on signal, means we applied the positive pulse to the gate terminal. We applied the positive pulse to the gate terminal. When we applied the positive pulse to the gate terminal, then it is a short circuited one. Okay, so whatever the information is there at the drain, that will be seen at the source point, and whatever the information we are having, this will be stored in the form of the charge across the capacitor. It will get stored inside the capacitor. So after some period of time, it is a continuous pulses now. So after some period of time, means after this period of time, we are applying the 0 volts now. Because of that, this particular gate will get open. Means this particular switch is open. Previously it is a short, now it is in the open. So when it is in the open, then we don't have any input signal. Means this particular circuit is not receiving any input signal. This particular circuit is not receiving any input signal. So when it is not receiving any input signal, so as we know that if at all there is no active element, means if at all there is no energy supplied to the circuit, and we are having the storage element, and which is having some information, some charge inside it, then we know that the initial property of the capacitor is it will discharge the information. This particular capacitor starts discharging because the circuit is open. When the input signal is open, when this particular switch is open, then the input voltage is not applied. So when the input voltage is not applied to the circuit, as it is we don't have any active element in this particular circuit, because of that, the charge across the capacitor will start the discharging by supplying the charge which is stored inside the capacitor. So like that, the information will be applied to the voltage follower, and at the output we are getting the sample information. We are getting the sampled information which is held inside the capacitor. So if you see this one, that's why if you see this particular diagram over here, if you see this one, so this is the input signal applied to the gate now. This is the input signal applied to the gate. So during how much period, means during the positive period or positive cycle which is applied to the gate, this particular circuit samples the input signal. So that time period is called as a sampling time period. Okay. So when you are applying supplying the 0 voltage to the gate, at that time it is acting as a open. It is acting as a open circuit. That means the switch is open. When the switch is open, then obviously we don't have anything, and during that period it is holding the information. Okay, it is holding the when the switch is open. When the switch is open, at that time whatever the charge previously stored by the capacitor, when the switch is closed, that will be hold for some period of time. Okay, so that time period is called as a hold period. Again, when you are applying the one more positive pulse to the gate terminal, again it will enter into the sampling mode. And when you are applying the 0 voltage, to the gate terminal, then obviously it is in the open circuit. That time period is called as a hold time period. Okay, so this is what we are having, the sample and hold circuit. So if you see this one, if you see this particular diagram, if you see this particular one, this is the input signal, and this is the input signal to the drain terminal, and this is the input signal to the gate terminal. So whenever this particular signal is having the active pulse, whatever the information is there during that period, that will get sampled. Okay, so means this information will be sampled and held by the circuit during the TH period. Clear? Okay, so means during the sampling time, whatever the input to signal variation is there, that is sampled and held by the sample and hold circuit. When it is open, then obviously it is not having any input signal. So the capacitor which is there in the sample and hold circuit, it will start discharging. So this is a sample and hold circuit explanation. Sample and hold circuit is nothing but whenever the device and whenever a particular device is not working with the same speed of the input signal variation, at that time we are using the sample and hold circuit as a mediator between the measuring device and the signal variation. So this particular mediator, that is a sample and hold circuit, samples the input signal variation and holds that one for the next level. And whenever the device is ready, it will read the information from the hold circuit. That's the sample and hold circuit. So this is all about your sample and hold circuit. And one of the application of the sample and hold circuit, in short, it is a analog to digital converter. Practically, we are able to see that one analog to digital converter. Inside the analog to digital converter, we are using the sample and hold circuit. Okay. So this is all about your sample and hold circuit. So next topic is isolation amplifier. The name itself says that this particular isolation amplifier, it is an amplifier only, but it is especially used for isolating some parameters, some connections, isolating some connections. What I mean to say that, especially this particular isolation amplifier is used in the industrial and the medical purposes. Industrial and the medical purposes, where we are expecting that there might be some electric shocks. To avoid the electric shocks to the human beings when you are trying to measure something, then we are using the isolation amplifier. Let me take the simple example for explaining the where exactly we use the isolation amplifier. So if you are taking the medical stream, in the medical stream we are having the means of when there is a patient, and if you want to keep on monitor, if you want, you can take the what is that ECG also, or if you yeah, you can take the ECG. So when you are taking when you are trying to take the ECG, obviously there are so many means that particular ECG equipment measuring the pulse rate of a body from different areas of a particular patient body. Okay, so means the strips are attached to the body, and the variation of the signals, the device will measure the pulse rate of that particular person, from the different areas of the body, and it is displaying the information on the screen. Okay, now if at all this particular ECG device is not grounded properly, and there is a huge amount of electric supply applied to the ECG device, there might be a chance that that electrical, whatever the higher electrical which is applied to the ECG, that may pass to the patient, that may be passed to the patient. Whenever it is passed into the patient body, obviously the patient will experience the electrical jerk, and there might be, and the patient may lose his breath. Okay, obviously the patient may die. Okay, to avoid that one, means when we are trying to measure the patient body, some parameters of the patient body using the instruments, in the hospitals. If at all the instrument is directly connected to the patient body, and there is an electrical shock, there might be electrical shock may pass from the instrument to the patient body, so that the patient may die because of the electrical shock. In order to avoid that one, we are simply using the isolation amplifier. The isolation amplifier is a one. What it will do is, it will act as a isolating parameter between the patient body and the measuring instrument. For example, as I took that ECG, so we are having the strips now. So we are having the strips, and means we are connecting the some sensing devices, or I can say that the sensors at the different parts of the body, and those are connected to the ECG equipment. Between the wires, which are connected to the human's body and the measuring instrument, I'm going to use the isolation amplifier. So because of the isolation amplifier, this isolation amplifier is not allowing the device, that is the measuring device, directly connected to the patient body. Means the isolation amplifier isolates the instrument from the physical connection to the patient body. Okay, patient body. At that time, the patient will not experience any electrical jerk or electrical shocks. Okay, so that is the best example for the isolation amplifier. So how we do that particular isolation process, means we use the couplers, wireless couplers. Means, let us suppose I would like to transfer some signal. From one point to another point without using any physical path. Then I'll go with the wireless communication. here also in the isolation amplifier, whatever the in the isolation amplifier we are using the just like the wireless, means we are sending the information in the form of the light or anything depending on what kind of device we are using as a isolation parameter, isolation device. Okay, depending on that, the information may be transferred in the different types of signals. Okay, we least bother about that one. We are only bother about when we are taking the isolation amplifier. When we are taking the isolation amplifier, it is coupling the, means if you take the example of the patient and the ECG device, where means some sensors are installed on the what is that some sensors are attached to the patient body, and those sensors are connected to the isolation amplifier, and without giving any physical connection to the, means without any physical connection, direct physical connection to the ECG, the measured information will be transferred to the ECG equipment in the wireless format. That may be in the wireless format. So means the signal is transferred from sensors to the equipment, sensor to the ECG equipment in the wireless format, and this pattern is called as a coupling pattern. What I mean to say that we used to call it as a signal couplers. We used to call it as a signal couplers. Let us suppose I'm having the human's body over here. It is a human's body, and I'm assuming that it is a measuring device. Okay, it is a measuring device and it is a human's body. Okay, between these I'm going to make use of one signal coupler, which is nothing but the isolation amplifier. So the measured information will be received by the isolation amplifier, and this information will be transferred to the ECG, as per our example, to the ECG. So between these two, means the information will between between the measured signal and the transfer signal, we don't have any physical path. We have only the common device, but we don't have any physical connection. So this element is called as a signal coupler. Signal coupler is nothing but which transfers the information from one position to another position without any physical contact. So that kind of device is called as a signal coupler. Okay, let us see the means what kind of devices we can make use as a signal coupler is a question. What kind of devices we can use as a signal coupler is a question. So we may use the photo transistors, we may use the Hall effect devices, we may use the thermal couplers, and the different types of devices we can make use as a isolation devices. Okay, so isolation device means they are the signal couplers without having the physical contact between the input and output. Here, this is the example for isolation amplifier. No? This is the example for isolation amplifier. So this is the output signal. Okay, this is the output signal, and this is the input signal which you would like to measure. But the measured information will be driven to the next level. This is the output device now, just like our ECG. This is the output device, just like our ECG, and this input signal means it is a patient. Okay, it is a patient. But between the measuring device and this, it is processing the measured information. Actually, it is processing the measured information. So I can consider this one as the entire thing as a input only. Okay, so it is an input part. Okay, so the measured information will be processed by the isolation amplifier, and this processed information will be supplied as an input to the output device. But between these two devices, between the input and the output devices, we don't have any physical communication. Instead, we are using the phototransistor, LED phototransistor as a signal coupler. Means the signal which is measured by the input device, that the measured information will be transferred to the output device by using the LED phototransistor. LED phototransistors means it is sending the information in the form of the light, and here we are using the phototransistor. This one is a LED which is blow means it is on and off. It will get on and off, and whenever it is in the on and off, and here we are using the phototransistor. The base terminal of the phototransistor is sensitive to the light. Whenever the light is falling, then it is read as the information. Whenever the light is off, then it is in the off mode. Okay, now means we don't have any physical connection between the LED and the phototransistor. So now it is acting as a coupler, signal coupler. LED phototransistor is acting as a signal coupler to couple the measured information with the output device. Okay. Now, so without having any physical connection between the devices, if you want to send the information from one device to another device, we are using the isolation amplifier. And especially the isolation amplifiers are used in the medical and the industrial stream. Okay, industrial means wherever the person wants to come deal with the high power supplies, then we are using the isolation amplifiers. I think in our India we don't have that kind of device, but in the foreign countries, when there is a huge current, means heavy lines, they are dealing with the heavy lines directly with the help of the sticks, and they are having the isolation amplifiers. Means when you are connecting that one to the stick, obviously we should get the what is that, electrical jerk, or electrical jerk. It is a jerk or shock that is not done by that particular stick, because we are having the what is that, insulator. So when we are having the perfect insulator, then obviously the electrical jerk will not pass to the human's body. Okay, so that is the main intention of the isolation amplifier. Okay, so this is all about your isolation amplifier. The next concept is a chopper amplifier. Chopper amplifier is nothing but, the main intention of the chopper amplifier is to amplify the DC signal. Means chops the signal, actually chops the signal, but we'll come to that point later. So chopper amplifier main intention is to amplify the DC signal. Using the amplifiers, we are using the amplifiers that is done by the chopper amplifier. Okay. In order to amplify the DC signal, whatever the circuit we are using, that circuit is very complex circuit now. To amplify the DC signal, amplification is nothing but what? Weak signal converted into the strength signal. So in order to convert the DC weak signal into the DC strength signal, we are supposed to use the amplifiers. So those amplifiers are called as a DC amplifiers. When you are trying to design the DC amplifiers to amplify the DC signal, the complexity of the DC amplifier circuit is very, very high. Okay, the complexity of the circuit is very, very high. So when we are having the more complexity in designing the DC circuits or DC amplifiers, what they have done is they have gone with the chopper amplifier. What the chopper amplifier will do is, it will amplify the DC signal but not in the DC form. It will amplify the DC signal and gives the DC output signal, but it is amplifying that particular DC signal not in the DC form. Instead, it is converting the DC signal into the AC signal, amplifies the AC signal using the AC amplifier, and convert back that information into the DC format. Constructing the AC amplifiers is little bit easy compared to the constructing the DC amplifiers. Constructing the AC amplifiers is little easy compared to constructing the DC amplifiers. So because of that, mostly we are using the AC amplifiers. When we are using the AC amplifiers, directly we can't supply, means we can't connect to the DC signal directly to the AC amplifier, because the AC amplifier is expecting the information in the AC signal, means alternating format, but the DC is a direct current, so it is not amplified by the AC amplifier. So because of that, DC signal should be converted into the AC signal, and the converted AC signal is applied to the AC amplifier, and the AC amplifier will amplify the AC signal, and that amplified signal will be converted back into the DC format. So in that way, weak DC signal is converted into the strength DC signal without using the DC amplifier. So that kind of circuit is called as a chopper amplifier. So here I didn't prepare the slide for that. I just took the snapshot of that. Okay. Now, so in this case, I forgot to write over here. This is a one transformer. This is one transformer, and this is another transformer. This is another transformer. Two transformers are there. One is a primary and another one is a secondary. Sorry, it is a input transformer. I'm assuming it is a this one is called as input transformer. This one is called as a output transformer. One is the input transformer and another one is the output transformer. So the input transformer is this one. This one is called as a input transformer. This entire thing is called as a input transformer. Obviously, we know that when we are taking the transformer, we are having the primary coil and we are having the secondary coil. This is a primary coil and this is a secondary coil. So in case of the output transformer also, this is a primary coil, this is a secondary coil. Okay. In this input transformer, I am assuming that the primary coil is a center tapped coil. The primary coil is a center tapped coil. In the output transformer also, I am assuming that the secondary coil, in the output transformer, secondary coil is a center tapped coil. Primary coil is not the center tapped one, but the secondary coil is a center tapped one. But in case of the input transformer, the primary coil is a center tapped one. Primary coil is a center tapped one. Primary coil is a center tapped one. Now, so this particular input transformer will take the responsibility to convert our DC signal. This is a DC signal. We are applying the DC signal into the AC format. DC signal into the AC format, that is in the pulse format. Okay. So that is in the pulse format. So in order to convert the DC is nothing but what? It is a direct current, and if you want to see, you can directly see that one. Wait a minute. And this if I am taking the red color to represent the signal. The DC signal is a straight line. It is converted into the alternate format like this. It is converted into the alternate format which is shown over here. Okay. So this is a direct current. Now, so as we are having the center tapped one, I am assuming that we have a switch which is freely movable one, which may connect it to the A terminal for some period and it is connected to the B terminal after some period. Means equal time period. Equal time period it is converted to the A, after that time period back to the B, A, B, A, B. As we know that, let us suppose this particular input DC terminal, this terminal connected to the A, means DC is applied to the A terminal. DC is applied to the A terminal. So obviously we can say that it is a positive and it is a ground. This one is already ground. Okay. So it is a center tapped one, so it is already grounded. It is a positive terminal. So I can say that a positive, as we know that there is an induced EMF will be developed in the secondary coil, as we know that one, right? So it will become the positive and it becomes a negative. It becomes a positive and it becomes a negative. So after some period, this particular switch connected to the G. This particular switch is connected to the G. At that time, this end is a positive and this one is already grounded. This one is already grounded. So when it is a positive, then obviously there is an induced EMF developed inside the secondary coil. Then it is a positive and it is a negative. Okay. During the first case, during the red mark, A pulse is appeared. During the green one, the B pulse is applied. Okay, means the direct current, which is a constant amplitude, is converted into the alternate format. It is converted into the alternate format with the help of the center tapped transformer. With the help of the center tapped transformer, that too, the primary coil of the transformer is center tapped one. Okay. Now, here in this box, it is not mentioned, but in this box we are having the AC amplifier. We are having the AC amplifier. AC amplifier. Okay, it is a AC amplifier. So the converted signal, which is in the AC format, will get amplified. Will get amplified by the AC amplifier, and we are having the strength signal, high intensity signal at the output of this particular one. And this particular high intensity signal compared to this one, it is having the high intensity. This particular high intensity signal is applied as an input to the primary coil of the output transformer. Primary coil of the output transformer. This is the output transformer. This one is output transformer. it is applied to the primary coil of the output transformer. Again, primary coil of the output transformer. No? So again, in this one, it is a primary coil and it is a secondary coil. In the output transformer, secondary coil is a center tapped one. Secondary coil is a center tapped one. Now, the information is in the high as well as the low. No? So obviously, it is a positive. During the first period, it is a positive, it is a negative. Obviously, it will be the positive. It will be the positive. And ground is already there. Okay. So this particular secondary coil output is constructing the DC signal, constructing back the AC into the DC format. So when it is in the positive format, then it is a positive, it is connected to the A. And after some period we come across this particular part, this particular part, at that time it is a negative, it is a negative, it is a positive, it is a negative, it is a positive. At that time this one becomes a positive, this one is already grounded one. But during this time this arrow, this switch or arrow, this one is connected to the terminal B. Again it is a positive only. Okay now. So when we are connecting like this, the center tapped secondary coil of the output transformer will construct the information back into the DC format. So during the positive pulse, this one is a positive and it is a ground. We have the positive voltage only. During the negative pulse, it is a negative, it is a positive. Because of that, it is a positive and it is a ground. Okay. So at that time, when it is in the negative pulse, the switch is connected to the terminal B. The switch is connected to the terminal B. So because of that, it is again the positive voltage. Means output is in the direct DC form. Output is in the direct DC. Okay, so which is represented over here. This is the amplified output, which is there at the primary coil of the amplified output, which is there at the primary coil of the output transformer, and it is the amplified DC output. It is the amplified AC output, which is there at the input of the primary coil of the output transformer, and it is a amplified DC output, which is there at the output of the or across the secondary coil of the output transformer. Okay, so this one is called as a chopper amplifier. What is the main implication of the chopper amplifier? Is the chopper amplifier is the one which is used for amplifying the DC signal by converting the DC into the AC, and using the AC amplifier we are amplifying the signal, and again that amplified AC signal will be converted back into the DC format. That is done with the help of the center tapped transformers which are used in the circuit. So this is all about your chopper amplifier. If you are having any queries regarding these topics, let me know in the group or you can comment in the comment section. Thank you.